So that covers the adrenal cortex. Let's move on to the adrenal medulla now. The adrenal medulla, as we had said before, is the center part of the adrenal gland. Okay, so in that medulla, chromaffin cells produce what are called catecholamines. Now, catecholamines occur in two different forms, epinephrine and norepinephrine, and they roughly have the same effect on the body. When norepinephrine or epinephrine are released, what they'll do is they'll bond directly to cell membrane bound receptors and initiate a whole bunch of different effects in the body. So you can imagine, since this we've talked about in class and online before, this is the fight or flight response. So it increases heart rate. So it causes more rapid influx of calcium ions into heart muscle cells. It constricts blood vessels, which raises blood pressure. And it also does a whole bunch of other things. Releases blood sugar from the liver, makes your breathing go up, as your heart rate increases, generally your respiration increases. It's a really, really important response and a really important hormone to our survival, right? If you really got to have that just one little extra edge to get out of a stressful situation, which may be dangerous to you, it's always kind of nice to have that burst of adrenaline, which will make your body work that much better, at least temporarily. Now, the pineal gland is located in the diencephalon. So that's kind of like the core of the brain. It's underneath the white matter and underneath the cortex. The pineal gland produces a hormone called melatonin. Now, melatonin causes drowsiness. Generally, it affects the brain and lowers your awareness and brings you down to a more, more into the subconscious than the conscious, eventually putting you to sleep. What activates this gland is decreased light. So if you think about it, we've had electric lights in houses for, I don't know, 120, 130 years or so. Well, we've evolved over a much longer period than that. That's only maybe 4 generations away that we've actually had electric lights in the house. So decreased light, our bodies have adapted to adjust to that and basically turn our brain off a little bit, make us go to sleep. We are diurnal creatures. We're much better walking around in the daylight than we are, at night. Just we're adapted for the light, daytime, activities. So when that light starts to dissipate or starts to, become less intense as the sun goes down, this is what, sort of helped us, I guess, fall asleep all together as a group, for social protection and that kind of thing. This is a problem, though, unfortunately, for people that work, like, say, like the graveyard shift in low light conditions. I'm thinking more like truck drivers. If you have very little light that you're exposed to, once that sun goes down, it kind of activates your pineal gland. And if you're just looking at those dim dashboard lights or, the headlights on the other side of the median on the highway, that's generally not enough light to stop the pineal gland from producing melatonin. Now, if you work in an office building with artificial lights, it's generally not a problem. But unfortunately, people that just don't work in very lit conditions have this issue. Now, if you think about it and take this to the very extreme, what about unsighted people or blind people? They can't see light at all. So how does their pineal gland, however they lost their sight, how does their pineal gland function? Sometimes it doesn't function on a normal cycle. It can drift. So there's actually a commercial out, if you've seen it on TV. It's called non-24 syndrome, where people that are unsighted, they might get up at 3 in the morning and be ready to go to work when everybody else is still asleep, or they might want to fall asleep at the end of their shift, if they have a job, which can be really problematic. So the pineal gland is stimulated by the light that you see during the day. So you know what question I'm going to ask you on the quiz, right? What's the form of stimulus to get the pineal gland to produce melatonin? And there's three choices. There's humoral, there's hormonal, or there's neural, right? So obviously the answer to this question would be neural, because your brain is, giving your eyes rather are giving your brain light information, which is turning this gland on and off. Okay. So the pancreas is the organ most directly related in regulating blood sugar. So there are two hormones produced by the pancreas. One is called glucagon, and one is called insulin. And I just want to say, even though I probably would say this in class, I can't compensate for everything that I would do in class online, right? I want to make sure you understand that glucagon and insulin are antagonists to each other, which means Glucagon is trying to always pull blood sugar up, and insulin is always trying to pull blood sugar down. And when these two, kind of like are balanced, then your blood sugar should stay at a relatively constant, healthy level. When one of them goes off, it's either overproduced or underproduced. That's when problems arise. Okay, so glucagon is produced by alpha cells in the pancreas when blood sugar is low, and we call that hypoglycemia. Insulin is produced when blood sugar is high by beta cells in the pancreas. So if you want to look at it, the pancreas, just to give you an idea where it is, and we'll talk all about this when we do digestive system, your pancreas actually has a whole lot of jobs besides just regulating blood sugar. It's really important in producing digestive enzymes too. We're going to table that for now, and we'll just talk about, blood sugar regulation. So glucagon, when it's released from the pancreas, causes the breakdown of glycogen. In other words, liver starch. Animals store starch as glycogen, whereas like plants store starch as cellulose or just regular plant starch. So glucagon breaks that animal starch, what you're storing from past meals, into sugar, and then that goes into your blood. Glucagon also promotes what we just talked about in the last presentation, gluconeogenesis. So in other words, glucagon helps to create new sugars from non-carbohydrate sources like fats and proteins. The release of glucose from liver cells into the blood is also accomplished by glucagon, and that means blood sugar goes up when glucagon is released because of these three mechanisms. Now, the antagonist to glucagon would be insulin, right? So when insulin is released from the pancreas, it enhances the cellular uptake of blood glucose. This is what we talked about in class. So in other words, all of the cells in the body are pulling the sugar out of the blood, which results obviously in lower blood sugar, right? Because it's not in the blood anymore. It inhibits gluconeogenesis, and it also inhibits the breakdown of glycogen to glucose. So not only does it help cells pull sugar out of the blood, lowering blood sugar, but it also inhibits the mechanisms that are going to lead to new sugars being produced, either through gluconeogenesis or through the breakdown of glycogen in the liver. Okay, so what if that doesn't happen, right? Well, if you throw your balance out of whack between insulin and glucagon, and obviously here we're talking about low or non-functional insulin, that results in a condition called diabetes mellitus, or some people call it mellitus. But when people say that, it sounds more like an inflammation to me, so I just call it mellitus, okay? Since sugar cannot be absorbed into body cells with no insulin, blood sugar levels rise. That's what we call hyperglycemia, meaning there's lots of sugar in the blood. That stress causes the body, weirdly enough, to release more glucose into the blood. So think about it. Your cells are starving because they don't have the hormone that will let sugar in, right? So even though sugar's in the blood, it can't get into the cells, and they're the ones that actually need it for respiration. So what do your cells tell your body? We need sugar. So your brain tries to compensate by releasing more sugar. You still can't absorb it into your cells, and you can see how this can become like a downward spiral. Blood sugar keeps going up and up and up and up, and the cells still can't absorb it to do anything useful. So at the extreme ends of this, what's going to happen is gluconeogenesis from fat and protein conversion, because your body just thinks you need glucose, so it's going to release glucagon to do this, will result in ketones being produced, and they are waste products. That results in ketoacidosis. So what this means is ketones, which are just a class of organic molecules that you can have in your blood, lead to your blood dropping its pH. Keep in mind acids, and I think probably everybody knows this, acids are generally lower than 7 as far as the pH scale goes. So how do you know that somebody's actually going through a diabetic episode to this degree? Ketones are actually pretty volatile, right? So in other words, they evaporate really easily at body temperature. And if somebody's acting, kind of like they're in shock, they're not making any sense, they may have trouble with balance and that kind of thing. If you smell their breath and it smells like acetone, like nail polish remover, that's a really good indicator that they may be having a problem regulating their sugars, because all these ketones from gluconeogenesis are leaving their body by evaporating out of their lungs, and that's what allows you to smell it, right? So that can be a real problem. So how do you handle this? Well, you got to get them insulin as soon as possible so that their blood sugar can go down and their cells can absorb it, okay? So again, I know this is kind of a, a derived thing, but diabetes is so common. It's the second most common endocrine problem that we have in humans, the first one being thyroid problems. Um, if this doesn't make sense, this is a great topic to have class conversation because it pulls a lot of these concepts together. So we'll talk about that later. Okay. So diabetes symptoms are, well, there's three major ones anyway. So in the kidneys, the sugar will actually get, or sorry, in the blood rather, the sugar will get so high that the kidneys will get rid of sugar in the urine, which is really not supposed to happen. Your urine is not really supposed to be that sugary, right? Um, so that results in a condition called polyuria because the sugar helps to pull the water out of your blood, and that basically fills your bladder up way faster than it should be. And that's called polyuria, meaning you got to pee a lot, right? If you know anybody with diabetes, especially people that are just trying to figure out their levels of insulin and glucagon and trying to regulate it, you'll know that they go to the bathroom almost, pretty frequently, right? Because they just have to urinate all the time. Well, if you're constantly getting rid of water with the sugar that you're trying to excrete from your body, obviously you're going to be thirsty all the time too. And we call that polydipsia. So not only are you drinking lots of water, but you're also excreting lots of water with sugar in it, right? So that leads to frequent urination as well as frequent drinking. Now, if your body constantly thinks that you need more blood sugar, that's going to make you feel hungry all the time. So people that are diabetic are generally, craving, food all the time simply because their body thinks that they need to, put sugar back into the blood, right? So that's polyphagia. Phage means to eat. So these are the three major, sort of the giveaways that people have diabetes. Really quick story. I like to fish, so my brother-in-law and I were on a dock trying to fish and everything, and it was like, 6 in the morning. He went to the bathroom probably, I don't know, 4 times an hour for the first 3 hours that we were there. And he's like, oh, I had a lot of coffee today. And I was like, hey, Mike, have you gotten your blood sugar checked? And he's like, he's one of those guys that, I don't need to go get my blood sugar checked. I'm fine. I was like, do me a favor. If I catch the first fish, you get your blood sugar checked. And thank goodness I caught the first fish. And he actually went and honored the bet. Turned out he had type 2 diabetes, right? So, I'm glad we actually had that conversation, and it's kind of serendipitous, but he's now on the mend and regulating it. So we'll talk more about that and how diabetes affects people in class. Now, I was trying to fit all this in with this being the last video, but because the next little section is probably going to take more than a couple minutes to talk about, I'm going to make another one, but the next one will be really short, I promise. And then guess what? We're done the endocrine unit. So one more to go.